There's something everyone already knows. Light is fast, incredibly fast, 300,000 kilometers per second. The sun is 150 million kilometers away from here, and its light takes 8 minutes and 20 seconds to reach us. The closest star, Proxima Centauri, takes 4.5 years for its light to reach us. And the Andromeda Galaxy, which you can see with the naked eye on a clear night, reaches you after 2.5 million years of travel. That's what you were taught. Now let me show you something else. From Einstein's equations, not metaphors, not philosophy, the raw equations that any physicist can write with their eyes closed, a clear, measurable result emerges, confirmed in laboratories. For the photon itself, this 8-minute journey simply doesn't exist. It doesn't take any time at all, zero, absolutely none. The photon leaves the sun and reaches your eye at the same instant. It's instant, it's one and only instant. Emission and absorption are a single event. There is nothing between the two. Think this through with me. How is that possible? The explanation you're going to try first is this one. Photons move so fast that time for them slows down almost to zero. That's a valid intuition, but it's incomplete. This incompleteness hides something much more radical. Einstein's relativity tells us that the faster an object moves, the slower time passes for it. An astronaut traveling at 90% of the speed of light would age twice as slowly as a human on Earth. At 99%, his clock slows down by a factor of 7. At 99.9% by a factor of 22. And exactly at 100% the speed of light, time doesn't slow down almost to zero.
Ele para exatamente em zero.
But there's a second consequence that people usually forget. In the frame of reference of a moving object, distances also contract. At the speed of light, that distance contracts to zero. The 150 million kilometers between the sun and your retina collapse in on themselves. From the photon's frame of reference, the sun and your retina are in the same place. The photon's proper time, what physicists call tau, the duration measured by its internal clock, is exactly zero. Not almost zero, exactly zero. For the photon, there is no before or after. There is only this. But here, things get even stranger. Let me tell you about an experiment. In 1942, physicists Bruno Rossi and D.B. Hall went up to the top of a mountain in Colorado at an altitude of 1,917 meters. They wanted to count particles called muons, a kind of heavy electron produced when cosmic rays pass through the atmosphere at an altitude of 15 kilometers. From the moment they are born, muons decay. Their half-life at rest is 1.56 microseconds. Even at the speed of light, a muon travels only 468 meters in 1.56 microseconds. Well, 15 kilometers represent 32 half-lives. According to classical physics, less than 1 muon in a billion should reach the ground. Rossi and Hall counted 560 muons per hour at the top of the mountain, and 422 muons per hour at sea level. Not 1 in a billion. 422 per hour. That's time dilation, observable, measurable. Inscribed in the very matter itself. Muons travel at 99.995% of the speed of light. In their frame of reference, the 15 kilometers contract to just a few hundred meters. Their internal clock slows down by a factor of about 100. This is not a hypothesis. It's a measurement repeated thousands of times. The GPS in your phone corrects for this same effect every microsecond. Without this correction, they would drift several kilometers per day. And that brings us to something that Newton never imagined. If time can slow down, if it can dilate according to speed, if it flows differently for each object, then time is not what you thought it was. It's not a universal river. It's a dimension, just like space. Flexible, deformable, and light is its absolute limit. Wait, think about it one more time. Einstein didn't say that light is fast. He said something much more radical. Light doesn't belong to time. It doesn't have its own duration. It travels through space without ever traveling through time. And this property is not a minor detail. It's the reason why nothing can move faster than it. The speed limit of the universe is not an arbitrary boundary. It's the very edge of time itself. Going faster than light would be to exist without lasting. An impossibility. A logical impossibility, not just a technical one. Light doesn't cross time, it's its boundary. Now comes the part that still makes me want to sit down and stay silent for a few minutes. Look at the sky tonight. Find a star. Let's say it's 100 light years away from here. The photon that enters your eye at this very moment left that star 100 years ago, by your reckoning, by your own aging, by the time of your world. But for the photon itself, that star and your retina are not separated by 100 years. They are not separated by anything. They are in its space-time, the same point, the same instant. That photon didn't wait, didn't age, didn't travel. It simply arrived. Let me take you somewhere now. Every ray of light you've ever seen, this morning's sun, the flame of a candle, the screen in front of you right now, never existed within time. Every photon that touched your eyes was born and died in the same instant of zero duration. And it is through these things that have no duration that you perceive duration. It is through entities that have never lived that you see life. You move through time. Light, however, does not. And yet it is light that connects you to everything. The star that died millions of years ago, whose light keeps reaching us. There is an old photograph whose photons once bounced off the faces you loved. There are all the sunsets you've kept in memory. None of those photons lived, but you remember them. There's something about it that I can only call courage.